Hello everyone, this is Bhumika Mohan. In this video, I am going to talk about a topic related to mathematics, that is ANOVA Technique. Contents of this video are analysis of variance, that is ANOVA definition and ANOVA formula. Next, I am going to discuss what is the analysis of variance reveal, example of how to use ANOVA, one-way ANOVA versus two-way ANOVA, and some examples related to ANOVA applications and a solved example. What is analysis of variance? That is ANOVA. Analysis of variance, that is ANOVA, is an analysis tool used in statistics that splits an observed aggregate variability found inside a dataset into two parts: systematic factors and random factors. The systematic factors have a statistical influence on the given dataset, while the random factors do not. Analysts use the ANOVA test to determine the influence that independent variables have on the dependent variable in a regression study. Let's see another definition for ANOVA. ANOVA is a statistical tool to test the homogeneity of different groups based on their differences. ANOVA is the method of analyzing the variance in a set of data and dividing the variance into groups according to the sources of those variations. ANOVA is based on the principle that the total amount of differences in a set of data can be divided into two types: the amount that can be attributed to chance and the other that is caused due to specific causes. In a population, ANOVA is used to determine the difference between the means of the samples by analyzing the variation within each of the samples and related to the variation between the samples. While performing ANOVA, two assumptions are made where the first is that the samples are extracted from a normal population, and the second is that all factors other than those being tested are controlled. Now, let's talk about ANOVA formula. The below mentioned formula represents one-way ANOVA test statistics. Source of variation here within sum of squares SSW equals summation j equal to 1 to k summation j equal to 1 to L x minus x bar j whole square, and degrees of freedom is DFW equals k minus 1, mean squares MSW equals SSW by DFW, F equals MSB by MSW. Between SSP equals summation j equal to 1 to k xj bar minus x bar whole square, degrees of freedom DFB equals n minus k, MSB equals SSB by DFB. Total SST equals summation j equal to 1 to n xj bar minus x bar whole square, degrees of freedom DFT equals n minus 1. Alternatively, F equals MSD by MSE, MST equals SST by P minus 1, MSC equals SSC by N minus P, SSC equals summation N minus 1 into S square, where F equals ANOVA coefficient, MSB equals mean sum of squares between the groups, MSW equals mean sum of squares within the groups, MSC equals mean sum of squares due to error, SST equals total sum of squares, P equals total number of populations, N equals the total number of samples in a population, SSW equals sum of squares within the groups, SSB equals sum of squares between the groups, SSC equals sum of squares due to error, small s is standard deviation of the samples, capital N is total number of observations. Now let's discuss what is the analysis of variance reveal. The ANOVA test is initial step in analyzing factors that affect a given data set. Once the test is finished, an analyst performs additional testing on the mathematical factors that measurably contribute to the dataset's inconsistency. The analyst utilizes the ANOVA test results in an F-test to generate additional data that aligns with the proposed regression models. The ANOVA test allows a comparison of more than two groups at the same time to determine whether a relationship exists between them. The result of the ANOVA formula, the F statistic, also called the F ratio, allows for the analysis of multiple groups of data to determine the variability between samples and within examples. If no real difference exists between the tested groups, which is called the null hypothesis, the result of the ANOVA's F ratio statistic will be close to 1. The distribution of all possible values of the F statistic is the F distribution. This is actually a group of distribution functions with two characteristic numbers called the numerator degrees of freedom and the denominator degrees of freedom. Example of how to use ANOVA. The type of ANOVA test used depends on a number of factors. It is applied when data needs to be experimental. Analysis of variance is employed if there is no access to statistical software, resulting in computing ANOVA by hand. It is simple to use and best suited for small samples. With many experimental designs, the sample sizes have to be the same for the various factor level combinations. ANOVA is helpful for testing three or more variables. It is similar to multiple two-sample t-tests. However, it results in fewer type 1 errors and is appropriate for a range of issues. ANOVA group differences by comparing the means of each group and includes spreading out the variance into diverse sources. It is employed with subjects, test groups, between groups, and within groups. One-way ANOVA versus two-way ANOVA. There are two main types of ANOVA, one-way or unidirectional and two-way. There are also variations of ANOVA. For example, MANOVA, multivariate ANOVA, differs from ANOVA as the former tests for multiple dependent variables simultaneously, while the latter assesses only one dependent variable at a time. One-way or two-way refers to the number of independent variables in your analysis of variance test. A one-way ANOVA evaluates the impact of a sole factor on the sole response variable. It determines whether all the samples are the same. The one-way ANOVA is used to determine whether there are any statistically significant differences between the means of three or more independent unrelated groups. A two-way ANOVA is an extension of the one-way ANOVA. With the one-way ANOVA, you have one independent variable affecting a dependent variable. With a two-way ANOVA, there are two independents. For example, a two-way ANOVA allows a company to compare worker productivity based on two independent variables, such as salary and skill set. It is utilized to observe the interaction between the two factors and test the effect of two factors at the same time. ANOVA examples. One example of one-way ANOVA is the analysis of the exam performance of students based on their test anxiety. Another example is the classification of agricultural products on the basis of different seeds and different fertilizers used. Here, the agricultural output is the dependent factor, whereas seeds and fertilizers are independent factors. There are many more ANOVA examples. Applications of ANOVA is it is a useful technique for researchers in various fields like economics, biology, education, psychology, sociology, business or industry, and several other disciplines. It can be used in the agricultural field to determine the relationship between agricultural production and the types of fertilizers used. It can also be used to compare the gas mileage given by different automobiles. Here is a solved example. The following data is given. Types of animals, dogs, number of animals 5, average domestic animals 12, standard deviation 2. Cats 5, 16, 1, hamsters 5, 24. Calculate the ANOVA coefficient. Solution. The following table is constructed. A square of n of dogs is 5, x is 12, s is 2, and s square is 4. For cats, n is 5, x is 16, s is 1, s square is 1. Hamster, n is 5, x equal to 20, s is 4, s square equal to 16. P equal to 3, n equal to 5, and capital N is 15, x bar equal to 16, SST equal to summation n x minus x bar whole square, that is 160. MST equal to SST by P minus 1, MST equal to 80. SSE equal to summation n minus 1 into S square, that is SSE equal to 84. MSE equal to SSE by n minus P, where SSE is 8,415 by 38,415 minus 3. That gives MSE equal to 7, F equal to MSD by MSE, where MSD is 80 and MSE equal to 7. That gives F equal to 11.429. Thank you.